So we ended up with 6 out of 22, and that translates into a percent of 27. Alright, for number 1, that one factors out, and you should have zeros of -2 and 6. The axis of symmetry comes out to be 2, and the vertex will be 2, -16. Of course, you get the -16 from plugging in the axis of symmetry into the equation. And you could find 2 points after that to make your graph more accurate, but I went through on a graphing tool and just made the graph. So you can see the vertex is +2, -16 here. And I can zoom in on that. Here's the graph. +2, -16, and then your zeros, -2 and 6. And then whatever 2 points you came up with to finish out the graph. On number 2, you can't factor that. So you have to use the quadratic formula. And when you use the quadratic formula, it boils down to -3 plus square root of 5 over 2 and -3 minus square root of 5 over 2. So when you go to put those on your graph, clearly there's no hash mark that says -3 plus square root of 5 over 2. So what you have to do is actually punch in square root of 5 and add it to -3 and then divide by 2, and you'll come up with a decimal that you can approximate over here and here. So actually work these out in your calculator so you know where to put them on the x-axis. But for your axis of symmetry, you just need the b and the a from the equation, which works out pretty neat. It's a -1.5, and that's where it's at here in the middle. And then put that -1.5 in whatever form you need to back into the equation. I made it a -3.5, or -3 over 2. And evaluated that out to get a -1 1/4, which would be -1.25 if you get a decimal. So you're going to put that as your vertex, and there it is, here. So with those 2 points and the vertex, you could go find 2 other points. And that's just a matter of, you can pick out an integer off the x-axis. You don't have to use something that's exactly 1 away from this and this. You can make it easier on yourself and pick integers that are easy to work with. And that's not a difficult equation. So you could come up with 2 more points and then plot your graph. I'll record it. This is a quick practice on the quadratic formula. So -b, you would have -4 plus or minus the square root of 4 squared minus 4 times 1 times -21. All of that over 2 times 1. So we'll just move up a little bit here. So that's -4 plus or minus the square root of 16 plus 84. You'll know that it was factorable in the beginning if you get a perfect square under there. So -4 plus or minus 16 and 84 is 100. What's the square root of 100? 10. So we have -4 plus or minus 10 over 2. So that's -4 plus 10 over 2 and -4 minus 10 over 2. That is a 6 divided by 2, which is 3. And this is a -14 divided by 2, which is -7.
Okay, that's what confused me then.
So there's your zeros. If you do the quadratic formula and get 3 plus or minus the square root of 2 over 3. So there's not much more you can do to that. So what you would have to do in your calculator is 3 plus the square root of 2 and then divide it by 3. And if you get a decimal, just round it to the 10th place. That should be enough to go graph it on the x-axis. Don't round it to the nearest one because it'll be off on your graph. But if you go to the 10th place, that's accurate enough to get a good graph. And then of course you'd have to do this too. Evaluate that top, divide by 3, and you'll come up with the other one. Well, here's number 3. And number 3 starts off with a negative. Just because you have a negative doesn't mean that you can't factor it. First of all, what's the first thing you notice about the entire problem due to the fact that this is negative? What has changed in our graph? What's different about the graph?
Oh, it's going down.
It goes down. So if you start with a negative x squared, it's going to go down. But just because it's negative doesn't mean you can't factor it. You can try to factor it by taking out a negative 1 all the way through. Notice I took it out and that changed the sign of everything else. So if to factor,
You didn't teach us this part to do with the graphs.
well, here it is.
We're being nice.
You have a negative 1 that you take out from all this, and when you do that, it puts it into a form that you can factor. So you have 3 and 2. 3 times 2 is 6, and then 3 plus 2 is 5. So that does factor out. And you do end up with zeros of negative 3 and negative 2, as you see here. But that negative 1 means that the graph is going to go down. So you can't forget that you had a negative 1 to start with. And then from there on out, it's the same process as before. You find the axis of symmetry. This is a negative 2.5. And your vertex would be right here, which is going to be negative 2.5 and 1/6 after you evaluate. And if you go to find 2 points from either side, you can put them down here and then graph it. Number 4 could not factor out, so I used the quadratic formula, and it boiled down to 1 plus or minus the square root of 3. So you'd have to do 1 plus square root of 3 and 1 minus square root of 3 to get your zeros. And if you get decimals for those, they end up being there and there on the x-axis. And the axis of symmetry is going to be 1. And if you plug the 1 into the equation, you get back a 3. So notice there is the vertex 1, 3 here, axis of symmetry down through it, and you could find 2 more points that could end up on either side. And this one was negative, x squared to start with, so that's why it goes down.
Wouldn't it be square root of 6?
Square root of 6 from here, that breaks up as square root of 4, square root of 3. And the square root of 4 is 2, and you still have the square root of 3. Alright, so number 5, you can't factor that one either, so there's the quadratic formula. And it boils down to negative 1 plus square root of 17 over 2, and then the other way with minus. So you just have to get decimals from those and plot them on the x-axis as accurately as you can. And then the axis of symmetry is a negative half. Plug it into the equation and get back a negative 4 and 1/4. So there's the negative half and 4 and 1/4 right there. And just get 2 more points of your own choosing. And this one goes up because the x squared was positive. Well, here's an example. Here's one with a negative x squared on it. So you have an option here. First option is to see if you can factor it. And if we can factor it, it would be to our benefit to take out a negative 1 and change the sign of everything through here. Set it equal to 0. So we took out a negative 1 and we changed the sign of everything. Now once you do that, it's not a guarantee that it's going to factor. You have to actually check it out. So if we look at the positive 6 and the negative 5, are there 2 numbers that I can multiply by 6, or not multiply by 6, but multiply together to get positive 6 and then add to get a negative 5? Negative 3 and negative 2 is right. So you would do this and put x minus 3, x minus 2. So it can factor out. Well, the x squared is taken care of by this point here.
Oh,
when you go back and multiply them out.
I leave it up there because I don't know how much.
Yeah, when you go back to multiply this out, you would get back to this. That's why there's no x squared here. Okay, so your zeros are what? 3 and 2, the opposite of these items there. So now it's the axis of symmetry. That's a negative b over 2a. So what's my b? 5. And the a is what? Negative 1. You have to refer back to the original equation here. So it's the axis of symmetry is going to be what as a mixed number? As a mixed number, it would be what?
1/2.
Not 1/2.
Wait, wouldn't it be negative 5 over?
Negative 2, which cancels out to 5 over 2.
Oh my gosh.
What's the mixed number of 5 over 2?
2.
2.5, yeah. And it's better to have a mixed number so it's more easy to graph. But we have to come up with the vertex. So for the vertex, we have to plug in that 2.5. And however you do it is fine. You don't have to work it out. As long as you plug it in and then do it in the calculator, it's fine. I'm putting in a positive 5 over 2 so I can do it on the screen. And then we'll go back and work this out. That's going to be a negative 25 over 4 plus 25 over 2. And if I get well, I don't want a common denominator yet, but now I do. So negative 25 over 4 plus 50 over 4, and that would be minus 24 over 4. This plus this is 25 minus 24 is 1, so it's 1/4. Your vertex would be 2.5 and 1/4. On this, I don't think we have to change the scale on this graph because I'm not seeing anything in our points that's anything extreme. So we'll go here in blue, and I think I have to up the marker just a little bit. The zeros are 3 and 2, so we'll go over here to 3 and 2 and make a dot. There's 2, and then there's 3. Then we will have a vertex of 2.5 and then up 1/4. So if you take a look at this, if we go over to 2.5, here's 2.5, and if I go up 1/4, it's not going to be far above that x-axis. So we can just stay here zoomed in on this part here. And if I want to find some other values, I'm going to go on either side of this. So we could try 1 and 4 and see what we come up with. So I'm going to have to zoom out. We'll use 1 and 4. And correct me if I'm wrong, but was it negative x squared plus 5x minus 6? Okay, so if I put in a 1, then I'm going to come up with a negative 1 plus 5 minus 6. That's going to be a 4 minus 6, which is 2 on that one. And then...
Would that be negative 2?
Oh, yeah, you're right. That would be a positive 4 minus, that would be a negative 2, yes. So we've put in 1 and came back with a negative 2. So we'll do this again, and this time we'll do it for 4, so that would be a negative 16 plus 20 minus 6. So that's a 4 minus 6, which is negative 2. So we put in a 4 and came back with negative 2. 1 negative 2 and 4 negative 2. So we'll go back here and go over 1 negative 2 and then over 4 negative 2.
Will they always have the same second number?
Yes.
Okay.
Yeah, if you space them evenly, now if on those ones that came out decimals, if you don't go the same exact amount away, you'd have to go 1 away or the exact same amount from it on both sides, and then those could be different if you don't do that. But this one here would be kind of hard to draw without getting an extra 2 points. But I'll give it my best shot here. We'll put this in a darker pink. There we go. So we'll try this, and you have to make it curve like that. No straight stuff in there. It's not a line. Alright, if we want to try to factor this, let's see if we can take out a negative 1, if that will help. And it'll give you an x squared plus 6x plus 8. Set it equal to 0. And I believe you can factor it as x plus 4, x plus 2. 4 and 2 add to get 6 and multiply to get 8. So your zeros are going to be negative 4, negative 2. Your axis of symmetry is going to be negative b over 2a. So that's a negative 6 over 2 times a negative 1. So you would come up with a negative 6 over negative 2, which is 3.
Okay.
Oh, there's a double negative, so it is a negative 3. You're right. Yeah, it's a negative 3. Axis of symmetry is a negative 3. So we'll go to the vertex, and on the vertex we will have a negative 3 squared minus 6 times a negative 3, and then minus 8. So this will be a negative 9 plus 18 minus 8. That's going to be 9 minus 8, which is 1. So we would have a vertex of negative 3, 1. So Rayburn, you went out negative 1, negative... yours was wider on that one. Pemberton, yes. Pemberton, Collett, Sexton. Let's see. What about this one? Huey, yeah. Huey's got that. Bobby Joe's got it. Davis. Applegate, yours was on the right side.
I know. I missed my negative 1.
Alright. There's no homework tonight. And we'll do some more of this tomorrow.